You feel weight right now. It's constant, familiar, impossible to ignore. Your body presses into the ground, your feet carry your mass, and everything about that sensation tells you one simple story. Something is pulling you down. That's something you've always been told is gravity. It feels obvious. It feels undeniable. And yet, that feeling is misleading you in a very fundamental way. Because here's the strange part. You've never actually felt gravity itself, not once. What you feel is pressure, the ground pushing up against your feet, the chair supporting your body, the surface resisting your motion. That's the real physical sensation. A push, not a pull. The idea that you're being pulled downward is something your brain assumes, not something your body directly experiences. Think about it carefully. If gravity were something you could feel, you would sense a force dragging you downward, independent of anything else. But that's not what happens. The moment that support disappears, the moment the ground is no longer there to push against you, that feeling of weight vanishes instantly. You don't feel a stronger pull. You don't feel yourself being grabbed and dragged. You feel nothing at all. Just motion. This is where the illusion begins. Your brain connects two events, pressure from below and motion downward. It creates a simple explanation. There must be a force pulling you down, and the ground is pushing back. But what if that explanation is backwards? What if the push is real, but the pull is just an assumption layered on top of it? Suddenly, something as ordinary as standing still becomes deeply strange. Why would you need the ground to push you up if nothing were pulling you down? Why does the sensation of weight disappear the instant that push is removed? These are not small details. They are clues. Clues that the way you've been thinking about gravity might not just be slightly wrong, but completely inverted. If what you feel isn't gravity pulling you, then something much deeper is happening. And to understand it, we have to rethink one of the most basic ideas in physics, motion itself. It feels obvious that things need a push to move. A ball sits still until you kick it. A book stays on a table until you lift it. Everything around you seems to confirm the same idea. Motion requires force. But that intuition is backwards, completely backwards. Motion is not what needs explaining. Rest is, imagine a perfectly smooth surface with no friction at all. You give a ball a gentle push. What happens next in your everyday experience? It slows down and stops. That's what you expect. But remove friction, remove every tiny resistance, and the ball would never stop. It would keep moving in a straight line forever, at the same speed without any additional force. Motion continues naturally. It doesn't need to be maintained. This is inertia. The tendency of objects to keep doing exactly what they are already doing. If something is at rest, it stays at rest. If it is moving, it keeps moving in a straight line. No effort, no energy input, just continuity. For a long time, people believed the opposite, that motion required constant pushing, and that stillness was the natural state. But careful experiments revealed a different truth. The reason things stop isn't because motion fades. It's because something interferes. Friction, air resistance, surfaces, all of these oppose motion. They slow things down, redirect them, and eventually bring them to rest. When you roll a ball across the floor, it stops not because it ran out of motion, but because countless tiny forces are acting against it. Remove those forces and motion continues indefinitely. Straight, simple, uninterrupted. Now here's the part that doesn't fit. If the natural motion of objects is a straight line, why doesn't everything move that way? Why does a thrown ball curve downward? Why does the moon circle the earth instead of flying off into space? Why does anything fall at all? These motions are not straight. They are constantly bending, constantly changing direction. And according to inertia, that shouldn't happen without a cause. Something must be acting every moment, altering the path. Something must be bending motion away from its natural straight line. For centuries, that something was called gravity, a force pulling objects toward each other. It seemed to explain everything. But as convincing as that explanation sounds, it hides a deeper problem. Because if gravity is a force, then we need to ask a much harder question. How does that force actually work? For centuries, gravity as a force seemed to solve the problem completely. Every object attracts every other object. The more mass something has, the stronger the attraction. The farther apart they are, the weaker it becomes. With this single idea, the falling of apples, the motion of planets, and the paths of comets all fell into place. It felt like the final answer, a simple rule governing everything from the ground beneath your feet to the stars above. Imagine throwing a ball forward. Instead of moving in a straight line forever, it curves downward and hits the ground. According to this model, Earth is pulling it constantly. The same thing happens on a much larger scale with the moon. It is moving sideways through space, but Earth's gravity pulls it inward, bending its path into a continuous orbit. The moon is falling all the time, but it never lands because its sideways motion keeps it missing the Earth. It falls around the planet instead of into it. This idea was incredibly powerful. It allowed scientists to predict the motion of planets with stunning accuracy. It explained tides, eclipses, and even led to the discovery of new worlds. When Uranus moved in a way that didn't quite match predictions, astronomers calculated that another unseen planet must be influencing it. They looked where the equations pointed and found Neptune almost exactly there. That is how successful this theory became. But beneath that success was a quiet problem that never went away. If gravity is a force, how does it actually act across empty space? There is no visible connection between objects, no rope, no medium, nothing you can point to that carries the interaction. And according to the theory, this influence happens instantly. Change the position of one object and another responds immediately, no matter how far away it is. Even Isaac Newton himself was uneasy about this. He could describe gravity with remarkable precision, but he could not explain its cause. He admitted he didn't know how one object could influence another across nothingness. He gave it a name, action at a distance. But that was just a label, not an explanation. So here's the contradiction. The theory predicts reality perfectly, yet it cannot tell you what gravity truly is. It explains the behavior, but not the mechanism. That gap remained hidden for a long time because the results were simply too good to question. But eventually, someone did question it, and that question would completely change how we understand motion, space, and reality itself. The real shift begins when you stop asking what force is causing motion and start asking a different question. What if no force is needed at all? What if objects aren't being pulled, but simply moving the only way they can? This idea seems strange at first because everything you see appears to involve forces, but that appearance comes from how you interpret motion, not from what motion actually is. Albert Einstein approached the problem from a completely different angle. Instead of focusing on forces, he focused on experience. Imagine you are inside a sealed room with no windows. You feel your weight pressing you against the floor. Now imagine that same room floating in empty space, but accelerating upward at the same rate. Inside, everything feels identical. You cannot tell whether you are in a gravitational field or simply accelerating. This is not a coincidence. It is a clue. This idea, known as the equivalence principle, suggests that gravity and acceleration are not separate things. They are the same phenomenon viewed differently. If that is true, then the feeling of weight does not come from a force pulling you down. It comes from being prevented from moving naturally. Now consider what natural motion really means. According to inertia, objects move in straight lines unless something changes their path. But what if those straight lines are not what you think? Massive objects like Earth do not just sit in space. They change the structure of space and time around them. They curve it. So when an object moves near Earth, it follows the straightest possible path through that curved structure. From your perspective, that path looks like a curve downward. An apple falling from a tree is not being dragged toward the ground. It is following the geometry of space-time. It is moving as freely as possible. You, standing on the ground, are the one being forced away from that motion. The surface beneath your feet pushes you upward, preventing you from following your natural path. That push is what you feel as weight. Even light follows this rule. When it passes near a massive object, its path bends. Not because something pulls on it, but because the space it travels through is curved. Everything apples, moons, light itself moves according to this hidden geometry. Once you see this, the idea of gravity as a force disappears. In its place is something deeper, motion guided not by pulls, but by the shape of reality itself. Now bring this back to something simple. The feeling in your body right now, the pressure in your feet, the weight in your legs, it feels like gravity pulling you down. But you already know that's not what's happening. What you're actually feeling is the ground pushing you up, constantly preventing you from following your natural path through space-time. This changes everything about how you interpret the world. When an apple falls, it isn't being dragged downward. It's finally free to move the way it naturally wants to. When the moon orbits Earth, it isn't held in place by a pull. It's following a path shaped by the curvature around it. Even astronauts floating in orbit aren't escaping gravity. They're moving along those same paths, just without anything pushing against them. What you call weight only exists when something stops you. A floor, a chair, the ground beneath you. These are not passive supports. They are active barriers, constantly pushing you away from the direction you would otherwise go. Remove that barrier and the feeling disappears instantly. Not because gravity is gone, but because you are no longer being resisted. This is the part that's hardest to accept. Standing still feels like doing nothing, but in reality, it requires constant interference. You are being accelerated upward by the surface beneath you, held away from your natural motion. Falling, on the other hand, feels like losing control, but it is actually the most natural state possible motion, without resistance. Once this clicks, the illusion breaks. The idea of gravity as a pull becomes unnecessary. Instead, everything becomes simpler and deeper at the same time. Mass shapes the geometry of space-time, and everything else follows that shape. No invisible strings, no mysterious forces reaching across space, just motion guided by structure. So the next time you feel your weight, remember this: nothing is pulling you down. You are simply being prevented from falling. And that subtle difference changes not just physics, but how you see reality itself.